In this video, we're going to take a look at how vertical displacement and phase shift affect sinusoidal functions. And then we're going to combine all the transformations of amplitude, period, phase shift, and vertical displacement and see how they affect the sine and cosine curves as well. All right, so to begin, let's take a look at what C and D do. Now, if you observe, the C is right beside the theta, it's within the brackets, but it's after the sine and the cosine. So the C translates the graph horizontally. The D, if you observe, is outside the brackets and it's at the very back, and D translates the graph vertically. So in trigonometry, we call the vertical shift a vertical displacement. So let's graph the following, and I want you to tell me what the vertical displacement and domain and range are. So in this first example, now like I've said before, I want you to always keep in the back of your mind what the basic sine graph looks like. So we're going to draw this. It goes from max of 1 to negative 1. We have 0, pi, and 2 pi, pi over 2, and 3 pi over 2. All right. Excuse me. So what's happened here is that we have this plus 1, and it's not inside the brackets and is at the very back. So we say that there is a vertical displacement of 1. So therefore, this means that this whole graph has now shifted up by 1. So instead of at 0, we're now going to graph it starting at 1. Now, what I usually do is when I see that there's a vertical displacement, I draw that central axis to help me and guide me where the rest of the points will go. So I'm going to draw this vertical or central axis at 1 because the vertical displacement was 1. So I'm going to graph the first point at 0, 1. I'm going to graph the last point at 2 pi, which I'll put here, and then also at 1. Okay, then I can label my other theta values by scaling. So we graph the middle point at pi and at 1, because remember, all these 3 points are all on the central axis. Excuse me. Now, since there is no amplitude, we haven't introduced that here, we're going to have an amplitude of 1 from the central axis. So this will be up at the top, and then at 3 pi over 2, it is now here at 0. So therefore, we know that the whole graph is shifted up by 1, and that's why now the top value is now at 2, and then the minimum value is now at 0. So we're going to connect our 5 points and a nice curve. And this does keep going on. I've only drawn a part of it. So we say that the domain is all real numbers. And then the range, however, is not from negative 1 to 1, but from 0 to 2, since it's now shifted up by 1. All right, so you can try the other one on your own. Now let's take a look at phase shift. So phase shift in trigonometry is what we call a horizontal translation. So phase shift is kind of just the fancy name in trigonometry. And it is the translation of the graph of this periodic function. So let's take a look at an example. And again, I have sine. And we're going to graph the following. And I want you to tell me the phase shift, domain, and the range. So we notice that inside the brackets, it's theta minus pi over 2. So we now know that this is pi over 2. And to help us a little bit more, because it's a minus, we know that this is shifted to the right. So again, keeping in the back of our mind what the sine graph looks like. I'm now going to shift this whole graph, this basic sine graph, pi over 2 units to the right. So if you think about it, this would look something like this. So we're now going to start at pi over 2. All right, so let's label everything. So we have 1, negative 1, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. So we start at we start at pi over 2 because it's shifted over. And then we know that the period is 2 pi, so because everything's shifted. So 2 pi away from pi over 2 is going to be 5 pi over 2. And then from there we can keep halving everything. So halfway would be this point here. And then we're going to draw this top point at pi and 1. And then we're going to draw this low point now, the minimum, at 2 pi and negative 1. And again, we can now connect all our points. Now this does again keep going to the left and to the right. So again, the domain is all real numbers. So the phase shift actually doesn't affect a cosine or a sine curve because it is always going to be all real numbers. And the range here, we haven't moved it up or down. So our range is going to be from negative 1 to 1. All right, so let's combine everything together. So when we have all our amplitude, period, phase shift, and vertical displacement all together, this is what the functions will look like. So A is at the very front, in front of the trig function. So A determines the amplitude. So if A is positive, we don't have to do anything. But remember, if A is negative, we must reflect over the theta axis, or our x-axis. B, notice B is inside the brackets here. Okay, so this whole piece here is what affects our theta. And B determines the period. And remember, the period is normally 2 pi, but we're going to now divide it by whatever the value of B is. If B is positive, again, we do nothing. But if B is negative, we're going to reflect over the y-axis. All right, C is also inside the brackets here. And C, which we just noticed, determines the phase shift. If C is a positive value, we're going to shift to the right. And if C is negative, making this to become a plus sign, we're going to shift to the left. And finally, we have D. Notice that D is not in the brackets and it's at the very end. It's outside. It's not connected to sine. It's added or subtracted at the end. And D determines our vertical displacement. If D is positive, we're going to shift up. And if D is negative, we're going to shift down. Now, before we find the phase shift, we need to make sure there's no coefficient directly in front of theta. If there is, we need to factor it out first. So let me show you an example where this will happen. So if we take a look here, we have 5 sine, and in the brackets we have 2 theta plus 6. Now it looks like our period, or the B value, is 2, which it is. But it looks like our phase shift is 6, but actually it is not. So what I'm going to do is I'm going to rewrite this as y equals 5 sine. And then I'm going to write bigger brackets. I'm going to factor out the 2, open another bracket, and then put theta plus 3. Close this bracket and close this bracket. Now we only factor from here, not the 7, because the 7 is not inside the brackets. So the 7 we still have on the outside. So if I wanted to identify all of these values, or our transformations, we have amplitude, which is 5. Our period, remember our period is always going to be 2 pi divided by whatever our B value is. So in this case, 2. So 2 pi divided by 2 is pi. Our phase shift is plus 3. So we're actually going to move negative 3, meaning we're going to move to the left. So we can say or 3 left. Our vertical displacement is going to be 7, and that will be 7 up. And then our domain, like always, is always real numbers. Now our range is going to be a little different, so you have to think about this. So we have moved up a vertical displacement of 7, so our central axis would now be at 7, but our amplitude is 5. So that means we're going to add 5 to get to our top line, which is now 12, but we need to subtract 5 to get to our bottom line, which is 2. So 2 2 to 12 is now what our range is. So we write this as 2 less than or equal to y less than or equal to 12. Now we're going to combine all of this to graph. So we're going to use transformations, or we're going to use key points. I actually like to use key points. If you use transformations, make sure that you apply the horizontal and the vertical stretches first, and then you apply the translations. So I'm going to show you how to use the method of using key points. And let's take a look at by doing an example here. So we're going to do a cos example, and we're going to sketch this over 2 cycles. So let's identify all of these features. So we have the amplitude, which is 2. We have our period, which is 2 pi divided by a third. So that's going to be actually 6 pi. Okay, then we have our phase shift, and we can see it's plus pi over 2. So it's going to be negative pi over 2. Vertical displacement is 1. And again, we know that the domain is all real numbers. And the range, actually, I'll do the range by looking at the graph after. Okay, so how do we start? So when we start by graphing key points, we always start first with our phase shift. Okay, so in the back of your mind, I want you to keep an idea of what cosine looks like. Now, this is what cosine looks like normally, but because of this negative sign, I'm actually going to redraw this so that I understand that, and keep in the back of my mind that cosine is actually negative. So it's going to look like this. So this will end at 2 pi. This is 0, pi, and we have negative 1 to 1. Pi over 2 and 3 pi over 2. All right. So the first thing we're going to do is we're going to start with our phase shift, and we're going to move this backwards by negative pi over 2. Actually, you know what? Sorry. We're not going to start with our phase shift. We're actually going to start with our amplitude and our vertical displacement. So we know that the whole graph has moved up by 1. So I'm now going to draw a central line here to show me that that's my central axis, or sometimes we call it a midline. Okay, and this is just a guide so that this represents this theta axis here. All right, so my amplitude is 2, so I know that my highest point will actually be up here. So I'm going to kind of just draw a dotted line to show me where that is. And I'm going to draw a dotted line on the bottom to show me the lowest point, the minimum it will go. All right, so we used our vertical displacement, and we've used our amplitude. All right, so now we're going to use our phase shift, step 3, and we're going to go backwards by negative pi over 2. Now I haven't plotted any values, so we don't really know what they are. So I'm actually just going to make every line pi over 2. So this will be pi, 2 pi, 3 pi, and so on. So I've labeled all the values on the theta axis, and I'm going to plot my first point, negative pi over 2. And notice that first point is down on the bottom here. So I'm going to plot that point right here. Now, because of the phase shift, my first point is at negative pi over 2. So what's going to happen is that my last point is going to be 6 pi away. So I'm going to add 6 pi to my first point, and that gives me 5.5 pi. So therefore, I'm going to graph my very last point here at 5.5. So 5.5 pi is, here's 5, so here's 5.5. Okay, then I know that from here to here, I'm going to count spaces, and I can see that this is 12 spaces. So I'm going to try to plot my middle point, which is in the middle. So half of 12 will now be 6. So I'm going to go 1, 2, 3, 4, 5, 6. And that point is at the very top. It's my maximum. So I'm going to graph that at the very top there. And then I'm going to graph this middle point here. And again, that is halfway between the first point and the third point. Knowing that this is 6 spaces, I'm now going to graph 1, 2, 3, plot it on my central axis. 1, 2, 3, which is my max. 1, 2, 3, which is again on my middle axis. And then I can now connect my 5 points. And then by counting 1, 2, 3 continuously, I'm going to graph my next period. And there you have it.